Page 119, continuing lesson 2.5 on proportional relationships. We look at example 3. A graph represents the cost per ounce of a granola cereal. A 15-ounce box of raisin cereal costs $3.90. Which cereal costs more per ounce? So always watch for this. One thing is they might be asking sometimes what's the better deal. They might be asking which one's not the better deal. So always be looking for that. So 15-ounce box is of raisin cereals, $3.90. So like we talked about in the first part of this lesson, what we can do here is then find the unit rate. When we want to find the unit rate, we want to divide the price by the other thing. So $3.90 divided by 15. And again, it's like we're dividing both of these by 15, but if you just take $3.90 divided by 15, you'll get the same thing, which is 26 cents per ounce. So raisin cereal is 26 cents per ounce. If we look at the graph for the granola cereal, what we can do is look for some points that are on the graph. This part, I don't like how the book's doing that. I think I've mentioned that. We'll mention it some more probably, but you can see here they've given us 2 points that are for sure on the graph. Another point that we could tell on the graph would be down here, would be 0, 0. If 0, 0 is one of the points, I like to use that point because it's easier to figure things out. Because what we're doing basically, there's other way we can get by with on this problem, but it only works for proportional relationships, so I'm not going to mention that to you guys so much here. Basically, we're trying to find the slope of the line. The slope is our rate of change, and when we divide it out, that's like our unit rate. So if we just look at 0, 0 going to 10, 2.5, and we're going to find a change in y and the change in x. So the change in y, if we're at 0, 0 and we're going up to 10, 2.5, the question is, how much is our y value changing? How much are we going up? And the answer is 2.5. Our y value went from 0 to 2.5, okay? If you want to, you can say we're taking 2.5 minus 0 to find that. Okay, but that change in y is 2.5. Change in x, we're looking at how far we're going over. How far are we going over from that point where we're at on the y-axis? And the answer is 10. Our x value is going from 0 to 10. So we're going over 10. And again, for that one, change in x, you could say I'm taking 10 minus 0 to get 10. That's the nice thing why I like using 0, 0. When you subtract 0, it doesn't change your numbers, so that's easy to subtract. And then what we can do is divide 2.5 by 10. What's going to happen when you divide by 10? It's just going to move your decimal one spot to the left. So that would be 0.25. And what that means when we divide that out, that's our unit rate. That's 25 cents per ounce for the granola cereal. So the granola cereal is 25 cents per ounce. And we said a minute ago the raisin cereal was 26 cents per ounce. The question is which one costs more per ounce. So we would say the raisin cereal costs more per ounce. And when you do this, when you look at the graph, as long as you pick 2 points that are for sure on the graph, you're going to get the same answer. So let's say instead of 0, 0 and 10, 2.5, let's say I'm going to use 10, 2.5, and 25. So it's the same thing, we could say what's our change in y, what's our change in x. So change in y, our y's, we're going up from 2.5 to 5. So if you do 5 minus 2.5, that tells us how much our y's change by. And this we'll have to watch as we go through these problems. I started with the 5 for the y value, means I need to start from the same point. So since I started with this y value, for the change in x, I need to start with this x value. So the change in x, we're going from 10 to 20. So we could do 20 minus 10. And what happens when you subtract? You get 2.5 over 10. And then if you divide that out, you'll get the same answer. Those are actually happen to be the same numbers as we picked before. We could even go from 0, 0 up to 25. 0, 0 up to 25. Our y would change by 5. We're going from 0 to 5. Our x would change from 0 to 20. And then that would be 5 divided by 20. 5/20ths is the same as 1/4, which is 0.25 also. So as long as you're picking 2 points that are for sure on the graph, then pick any 2 points, find the change in y, change in x, and divide, and you'll get the same answer. So if we look at the try it, distance covered by the fastest high-speed train in Japan traveling at maximum speed is represented on the graph. So fastest high-speed train in Japan is the graph. And then we have fastest high-speed train in the United States traveling at maximum speed covers 600 kilometers in 2.5 hours. And the question is, which train has a greater maximum speed? So probably the easiest thing would be to go ahead and look for the one with the United States, because they're telling us the numbers here. And again, we can think about for the speed whether we would want to do kilometers per hour or hours per kilometer when we're talking about the speed. And kilometers per hour would be what we would want to use here. Normally, in the United States, we use miles per hour. Other countries use kilometers per hour for their speed. So 600 kilometers, we know 2.5 is the same as 2.5. And so what we can do is just divide that out. And again, to make that quicker, we could probably use calculators. We can do it by hand if we need to, but if we just divide that out, find our unit rate. So if you divide that out as 240, so 240 kilometers per hour in the United States. If we look for the one in Japan, once again, we can pick any 2 points here. I'm going to pick 0, 0. There is a point here at 1 something, and we can kind of gauge that. Looks like it's more than halfway. So halfway would be 300. So it looks like it's going to be faster than that 240 we just had. These actually, none of them quite hit exactly on a point. This one up here is pretty close, but it's actually a little bit more than 3 hours, it looks like. So that would probably be what we would need to do on this one, is just kind of gauge that this is for sure more than 240. It's probably a little bit more than 300 even, maybe. And then we just have to gauge it that way. So that's saying that we're going up. Well, it's really already a unit rate because that's for 1 hour. And that's how many kilometers it went. So this is probably over 300 kilometers per hour. And so then we can tell that the train in Japan has a faster maximum speed than the one in the United States. One other thing we could look at for sure here is that in 2 hours it's over 600 kilometers. So Even if it was right at this point, which it's not, it's more than that. Right at that point would be 600 kilometers in 2 hours, which would be 300 kilometers per hour. So for sure, that's our point that we could tell definitely it is over 300 kilometers per hour. So the key concept, again, just talks about comparing proportional relationships, talks about finding the unit rate. This one is kind of like we actually did last year, which again, I don't want to get into too much, but if we have a table like this, we can just take the one divided by the other one. Again, usually price divided by the other thing. Once again, we're doing here. So we can see each one of these on this table would be $36 per hour. So it's the same for any amount. And then from the graph, I'll only do this a few more times. We can look at 2 points and then find what the change in Y was and the change in X. If they didn't tell me this point was 375, I wouldn't necessarily know that for sure. I mean, it definitely looks like it's there. What I would probably do otherwise is go with 0, 0, and 250, but it doesn't matter. Either way, over here, the Y's were going from 50 to 75, and the X's were going from 2 to 3. So that's 25 over 1, which is 25. If I would have done 0, 0, and 250, that would have been going up 50. Going from 0 to 50 is going up 50, and then over 2. What you have to watch on these problems is that their boxes aren't necessarily always going by ones. Like this one, on the X's, they're going by halves. On the Y's, each box goes by 10. Okay, yes, they're going by 20s with the numbers, but if we look at the in-between boxes, they're going by 10. So you can't just say, oh, I went up 5 boxes and over 4 boxes. You have to think about what the numbers are actually. So up 50 and over 2 gets me to that point. So that's 25. And then the other thing is the equation. The equation, we talked about this before. This equation is proportional. It's in this y equals kx format. And what I mean by that is there's nothing being added or subtracted. Okay, it's just y equals something times x. I know and the letters are changed here. They did C and T instead of Y and X, but it's the same idea. So this means 28. That would be $28 per hour for that one. And that's all we have to do on those. Those are real easy with the equations. We just look what that number is, what that coefficient is, and then that's our unit rate. So look at the do you know how number 4. Amanda babysits and Petra does yard work on weekends. The graph relating Amanda's earnings to the number of hours she babysits passes through the points 0, 0, and 424. So they don't have this graphed for us. They're just saying those are points that it goes through. The table relates Petra's earnings to the number of hours she does yard work. And the question is, who earns more per hour? So if we look at this for Amanda's earnings, they've given us 2 points. If you want to just sketch out a graph, even though they didn't give you a graph, you could just sketch something if you want, if that helps you. And say it goes through 0, 0, and 424. You don't have to necessarily mark all the points off there if you don't want to. And then what we can do, like we've been doing, is look at basically finding our slope of the line, what our change in y is and what our change in x is, if we were going from the one point to the other point. So our change in y, we'd be going up 24. And that's nice with 0, 0 is you can just see that y value there that you're at. Really what we'd be doing, just for safety's sake, future reference, because it's not always going to be 0, 0, we could do 24 minus 0. And then the change in x, we're looking at how far we're going over, and that would be 4. We're going from 0 to 4, and that would be 4 minus 0. Again, keeping the same order on the x's that we did on our y's when we subtract those. So that would be 24 divided by 4 would be 6. So what that means, if we look at this, this was earnings and hours. So this is the number of hours, and this is how much she makes in dollars. They probably should have defined their variables a little bit better there, but basically that's telling us that she made $6 per hour. So that's for Amanda. And then for Petra's earnings, they've got a table that we're going to look at. So on the table, we could do like what the book did at the beginning and just divide all of those out. And if they're proportional, then we'll get the same things. Another thing you could do, you could think of these as points. This is like 315, 630, and 945. And you could just look at those the same way. You could say, what's my change in y, what's my change in x, and then figure out that unit rate. And again, just to be consistent, so you guys don't have like two ways to remember, that would be my recommendation, just to go ahead and do that, and then you don't have to think, oh, am I doing it this way or this way now? So there's no decimals in these at all, so I would probably, if I was picking these, I'd probably just pick the smaller numbers. If you want to do something different, you can. But kind of, again, just think about if you were going from 315 to 630, and again, you can sketch that out if you want. Okay, not very straight line, but it gives us an idea anyway. Okay, so from 315 to 630, and we could think about what our change in y is and what our change in x is. So change in y would be 15. We're going up from 15 to 30. And again, to work that out, you could say I'm taking 30 minus 15. Okay. So we have to do the same order for the x's that we did for the y's. So the x's, our x value, we're going from 3 to 6. So that's a change of 3. Or to work it out, again, showing that same order that we did, we could do 6 minus 3. So that would be 15 over 3, and then we'll go ahead and divide that out, which would be 5. And what that means is Petra earns $5 per hour. So if we go back and look at our work here, if we can find it, Petra was $5 per hour, and Amanda was $6 per hour. So who earns more per hour would be Amanda. And specifically, we could say Amanda earns $1 more per hour than Petra. So if we look at number 5, it says Milo pays $3 per pound for dog food at Pat's Pet Palace. The graph below represents the cost per pound of food at Mark's Mutt Market. At which store will Milo pay a lower price per pound for the dog food? Okay, so which place is going to be a better deal? The one they already told us, so that's nice. $3 per pound. That was for Pat's Pet Palace. And then, so it's just a matter of looking at the graph here. So we're just going to try and pick out a couple of points that the graph hits. So 1 point, nicely, the graph goes through the point 0, 0. The other point, it's really not hitting anything exactly on until right at the end here. So if we just go one notch further than where we're at, that would be the point 520. Remember X and then Y when you list your coordinates. I mean, we could try to look at this one kind of like we did with the train problem. We could try to just eyeball it and say, yeah, that looks like that's more than $3 per pound, you know, at this first mark here. But, you know, that's not a total guarantee. Like I said, I think right here for sure that's over halfway. Halfway would be 2.5, so that'd be 250 per pound if we were halfway, and it's above that. So it's definitely more than 250. The question is just whether it's for sure more than 3. So that's kind of a close deal there. I probably wouldn't make that call if I've got another point to look at like I do. So just like we've been doing, we're going to look at what our change in Y and change in X are. So if we're starting at 0, 0 going to 520, the change in Y. So we're going up 20. We're going from 0 to 20. Again, looking at the Y values, those second numbers there. And then the change in X, we just look how far we're going over. Going over, we're going from 0 to 5. So keeping the same order, we do 5 minus 0, which would be 5. And then we're just going to divide 20 by 5. So that's 4, which means $4 per pound. So as we suspected, that is more than the other one was $3 per pound. So the lower price per pound would be at Pat's Pet Palace. These tongue twister names they've got. So we look at workbook page 29, number 1. Graph and the table show the total cost to the number of pairs of jeans purchased at 2 different stores. Which store charges the higher cost for a pair of jeans? So this time they're wanting the worst deal. So it says find the unit rate or constant of proportionality for Jenny's Jean Store. Jenny's Jean Store, notice it goes through 0, 0, so it is proportional. We can actually just tell by looking at that one right there. One pair of jeans is $20. Okay? So you could say over here, if you wanted to fill this out, the cost is $20 for one pair, so that's $20 per pair. Or you could use the point 0, 0 and 120 if you want. You change in Y is 20, change in X is 1. Okay? Unit rate for Jean Warehouse. Again, this one we could just divide them out. Technically. Otherwise, we could think of these as points. And any 2 points should do. Any 2 points, we should get the same answer. Again, if you want to sketch it out, you can. You don't have to. This time they're not just telling us for one pair, we got to work at it a little bit more. So again, we can look for a change in Y and a change in X. So we're going up from 36 to 54, so if we subtract those, we can find what that change is. And then the change in X, we would be going from 2 to 3, so if we subtract, again, going in the same order. So we started with the 54 for the Y, we need to start with the 3 for the X. So 3 minus 2. So 54 minus 36 is 18, 3 minus 2 is 1, 18 divided by 1 is 18, and that means $18 per pair. So $18 per pair at the Jean Warehouse, and it was the other one was $20 per pair. I mean, if you want to on this, what they're doing is they're just using the points in the table and just dividing those since it is proportional. But like I said, later we'll get into stuff that's not proportional, and you won't always just be able to say, oh, I'm going to take these two numbers and just divide them. So then we could say Jenny's jean store charges the higher rate. Number 2, the graph shows the average speed of car 1. So the graph is car 1 traveling on a highway. The equation y equals 55x represents the average speed of car 2, where y is the distance in miles and x is the time in hours. So the question, which car is traveling at a greater speed? I'm going to start with the easy one, which is the equation. So car 2 is the equation. That one is pretty much a gimme if we know what we're looking for. So from the equation, it's proportional. All we're doing is looking for that coefficient of x, the number next to the x. So that tells us that's going 55 miles per hour. Then car 1, we're going to have to look at the graph. So we can just find a couple points on the graph. So one point on the graph here is perfectly at 164. It does go through 0, 0, so it's proportional. So that is going to be our unit rate. It goes through 0, 0 also. If you wanted, you could say that. But that's going to be our unit rate. So that tells me it's going 64 miles per hour. Again, you could do like what we've done. We could say it's going up 64 and over 1. 64 divided by 1 is 64. Okay, so that's 64 miles per hour. This is car 1. And the question is, which one is traveling at a greater speed? 64 is more than 55, so car 1 would be the faster one. And again, we could write a sentence out just to, make that a nice statement to finish off the problem. Number 6, the graph shows the relationship between the time in minutes and the number of milk cartons machine 1 can fill. The equation y equals 22x describes the rate at which machine 2 can fill cartons, where x is the number of minutes and y is the number of cartons filled. What is the unit rate for each machine? So machine 2 with the equation is probably the simpler one. We can just look for that coefficient of x, which is 22. So that's 22 cartons per minute. Just the y divided by x units, so 22 cartons per minute. If we look at machine 1, they've got a couple of points kind of marked off for you here, but just because that doesn't mean you have to use those points. I see a 0, 0 here. It looks like there's a 125. Just to be safe, if you want to go with this 250, you can. And again, you can look at change in y over change in x. So change in y, if we're going from 0 to 50, that's a change of 50. Change in x, we're going from 0 to 2, so we're going over 2. So up 50 over 2, so 50 over 2. If you divide that out, it's 25. So that's 25 cartons per minute. And the other one was 22 cartons per minute. So we can see that machine 1 is faster. And it says how much faster, so a simple calculation, but we can write it out just to show what we're doing. 25 minus 22 is 3. So we could say machine 1 is faster by 3 cartons per minute. So this gives you an idea of how to compare proportional relationships.